Math 3, practice 3.2.1, proving the law of sines. So remember, the law of sines is stated like this, roughly, okay? That the sine of angle A over side A is equal to the sine of angle B over side B, which is also equal to the sine of angle C over C. So if I have a triangle, not necessarily a right triangle, in fact not a right triangle, because that's why we have this and we can't use the Pythagorean theorem and trig for this in a normal sense, is that this is angle A, side A is across from it. Angle B, side B is across from it. Angle C, side C is across. So the way we use it is we pick two of these to set equal to. So it could be these two, could be these two, could be these two. And we have to have three pieces of the information to find the fourth. Okay, it won't work otherwise. Now, you can also see it written. We can just flip the fractions, and we could do it like this. A over sine of A equals B over sine of B, and so forth. And C over sine of C. Okay, if it's the same thing, doesn't matter which way you do it. Usually we write it different ways because it depends on what you're looking for. So like question number 1, I want to know what FG is. Okay, we're looking for this side right here. So that side is opposite angle E. Okay, now do we have another connection of an angle in the side? We do. We have this angle F and its side across. Angle G really doesn't help us much. Okay, so I also want to find side E, little e, right? I probably write, usually we write it, the side is the lowercase. So if I want to find that, I put that on top. And then I say it's over the sine of angle E, which is 39 degrees, equal to the other connection I have. So 9 goes on top, over the sine of 104 degrees. Okay? Then what we end up doing is we times by the sine of 39 degrees on both sides. Those cancel, leaving us with E equals 9 times the sine of 39 degrees over the sine of 104 degrees. We type that into our calculator, and then that'll tell us what side E is. And when we type that in, we get E equals 5.837. Said round to the nearest hundredth, so that becomes a 4 instead of a 3. 5.84. Okay? And then you can kind of check it too, because there's a triangle law that says that the bigger the angle, the bigger the side across from it. Okay? So 39 across here, 39 is about 40, about, not quite half. So it's smaller, and so that's the, kind of what we're looking at here. All right? So now we take a look at number 2. Okay? So it tells us the measure of angle B is 2 pi over 3. What's the measure of angle A? So we find connections. B has a connection. A has a connection as well. So now here's when we want to do, because we're looking for angle A, we put the sine of angle A on top, over 7 feet equals the sine of 2 pi over 3 over 13. So we times both sides by 7, and we get the sine of angle A. So then I go 7 times the sine of 2 pi over 3 divided by 13. That'll give me the sine of angle A. That's not angle A, that's the sine of angle A. So let's put that in the calculator. Now we get 0.466 and some other decimals. Okay, we'll probably want to leave those decimals there and kind of use the calculator to help. Now, in order to get rid of this, or to get rid of the sine, to get A by itself, that's when we take the inverse of it, of the number, and that's going to give our angle A. So we use the calculator to do that. and we get 0.4851. Okay, so if we round it to 0.49, that means angle A is 0.49. Now, this isn't degrees. Remember, this is in radians. Okay, so it's hard for us to visualize that. So I usually don't try to. Okay, if we wanted to, we could turn both of these into degrees, like 2 pi over 3 times 180 over pi. Pi's cancel. 2 times 180 is 360, divided by 3 is 120. So that would be 120 degrees. In 0.49, we go 0.49 times 180 divided by pi. I just realized that I said a bunch of stuff without knowing where I recorded. I stopped recording. I think I stopped right here when I did that, and I got about 28 degrees, which then I said 28 plus 120 is 148. Subtract that from 180, and that would get us 32, and that seems like a pretty good idea. Anyway, so sorry if that was a little weird right there. Okay, now 3, 4, and 5, we're doing the same thing, this time without the picture. Okay? I like to draw the picture. I like to see what I'm doing. So we've got U, V, and W. UV is 6 millimeters. VW is 8. Angle W is 34. It wants us to find angle U. Okay? So look for a connection right there and right there. So we're doing it like number 2. So we'd go the sine of angle U over 8 equals the sine of 34 over 6. So I'd times both sides by 8, and I'd get the sine of U equals 8 times sine over 34 divided by 6. So I use my calculator for that. That gives me about 0.7449 something something something. Okay, using that in the calculator, because I hate to round too early, now I have to take the inverse sine of that to get what U is equal to. And we get about 48.21 if we round degrees. So angle U, the measure of angle U, is 48.21 degrees. Now let's take a look at number 4. Okay, number 4, once again, I'm going to, okay, that works. So we've got A, B, and C. BC is 7, angle A is 0.245 radians, angle C is 0.784 radians. What is the length of AB? So now we're doing the side. So side AB over, which would be side C basically, over the sine of 0.784 equals 7, that side, over angle A, the sine of 0.245. So I times by the sine of 0.784 on both sides, leaving me with AB. So I'd go 7 divided by the sine of 0.245 times the sine of 0.784. Put this whole thing in my calculator, and it'll spit out my answer for me. And we get about 20.738. So about 20.74. I transpose that. I meant 378. So about 38 inches. Okay, number 5. So let's draw our triangle. X, Y, Z. XY is 8. XZ is 7. Angle Y is pi fourths. What is angle Z? So going for angle of Z again, so I'd go sine of Z over its opposite, 8, equals the sine of pi over 4. over its opposite, 7. Times both sides by 8. Those cancel. So the sine of angle Z equals, and then I put that in my calculator, 8 times that whole thing divided by 7. We get about 0.808, but there's more decimal to it, so leave that in your calculator, and then you just code the inverse sine of 0.808, and the rest of that decimal equals angle 0. And it'll be in radians. And we get about 0.9409, so we can call that good for our radians. Okay? Alright, so there's those ones. Now we're going to take a look at finding the area and the perimeter. So we're going to have to use the law of sines to help us figure out the perimeter and the area. Now remember, for the area we have that formula using the law of sines, that the area equals 1/2. That's not a very good 2. 1/2 times A times side B times the sine of angle C. So the idea here is that whatever the triangle looks like, it's the angle in between two sides. Okay? So for number 6, we've got CDE. Angle C is 112. DE is 6. CD is 11. And EC is 8. So you have to choose that angle, but then this side and this side. We're not going to choose the side opposite the angle. Okay? Now we just put it into the formula. So A equals 1/2 times A, which is 11, times B, which is 8, times the sine of 112 degrees. Okay? Now I could just put it in my calculator like that, or I could simplify the front. 8 times 11 is 88, times 1/2 is 44, times the sine of 112 degrees. Then I get out my calculator, and I go 44 times the sine, 112 degrees. And that gives me about 40.79. Okay, or 40.8. And that would be in meters squared. Okay, so number 7, same idea. Tells me angle A is pi over 7. So angle A, and then these two sides. So it would be 1/2 times 11 times 9 times the sine of pi over 7. Type that all into my calculator, because that's what I'm going to do, and I get 21.48 when we round centimeters squared, because it's area. Okay, so that's all there is to using the area formula. Now 8 through 10 wants us to find the perimeter. Well, in order to find the perimeter, we need to know every side. So we're going to have to use the law of sines to figure out our third side. Okay, but I've got a connection here. I've got a connection here. Could I figure out this third angle? Yeah, I'd go 180 minus 45 minus 67, and I could use that one instead. Doesn't really matter. I've already got a pair, so I would go question mark over the sine of 67 degrees equals 10.4 over the sine of 45 degrees. So I times by the sine of 67 degrees on both sides. That leaves me with question mark on the left side. So I've got 10.4 times the sine 67 degrees over the sine 45 degrees. I type that into my calculator, and that'll give me my answer. So, 10.4 times the sine of 67 degrees over the sine 45 degrees. And I get my side length being 13 point, round to the nearest tenth, 538, so 13.5 kilometers. Okay, now is that my answer, my complete answer? No, because they want the perimeter. So I go 13.5 plus 10.4 plus 13.8 to give me a perimeter P of 37.7 kilometers. Okay, so number 9, same idea. Okay, now this time I don't have two sides. So I do have this connection, so I know that 5 over the sine of 34 is going to equal this side length over the sine of 29. So I times by the sine of 29, so I get the sine of 29 degrees times 5 over the sine of 34 degrees. So I get about 4.3. Okay, so that side is 4.3. Now I'm going to use that 5 over the sine of 34 to give me this new one, this longer side right here. Now what's that? Well, we go 180 minus 34 minus 29. So that angle is 117, so it would be the sine 117, which is what we multiply by. That cancels. Sine of 117. So our question mark equals, so let me do that again. So 5 times the sine of 117 divided by the sine of 34. And I get about 7.96. So 7, basically 8 if we round, because 9669. Round to the nearest tenth, that would be 10, so we'll call it 8. So 5 plus 8 plus 4.3 gives us 17.3 for our perimeter. Because remember, that's what it wanted us to get at. Basically, it's just seeing if we can get every part of the triangle. Alright, now the last one is in radians, but we still treat it the same way. So I need to find this side first. Okay. So I would get question mark over the sine of 0.436 equals 14 over the sine of 2.409 times by the sine of 0.436 on both sides, and we get, so it would be 14 times the sine of 0.436 over the sine of 2.409, which would give us about 8.84, so 8.8. Now, remember, we consider a triangle to be 180 degrees. In radians, that's pi. So if I go pi minus 2.409 minus 0.436, we'll get 0.297 if we round the same way they've been rounding. So then I go question mark over sine of 0.297 equals 14 over the sine of 2.409 times by the sine of 0.297 on both sides, and we end up with our answer. So kind of a different way you have to think about it. giving us 6.12, so 6.1. Add those all together, and we get our perimeter of 28.9. And there we go for this one.